First off, the concept of your hard and soft acid and bases. Okay, so a simple rule in predicting the stability of compounds from acid and bases. Okay, it was actually a person who qualitatively generalized the interaction of Lewis acid and base by classifying them into hard and soft um, category. Okay, so it was person who did this, right? So um, a simple rule in predicting the stability of compounds from acid and bases. Okay, so it was person. The convention is, remember this one. Okay, the convention is hard acid prefers hard bases, and soft acid prefers soft bases. Because if you have a hard acid and a soft base, this interaction right here, papunta dito, would be unstable, generally unstable. Okay, generally unstable and hard and soft. Okay, that is why hard acid prefers hard base. Okay, so what are hard acids? Okay, hard acids are ions now, or cations generally that have low size, okay, small size but high charge. Okay, soft acids naman has high or big size, now big size molecule and low charge. Okay, right. So right, the key takeaway here is hard refers hard, soft refers soft, and hard acids are low or small in size but high in charge. Soft acid naman are high in size, low in charge. Alright, so the concept of your H sub revolves around your polarizability. Polarizability is generally the only trend in your hard and soft bases. So remember this one, and it depends on your atomic size and number of electrons. Okay? So polarizability is the degree to which a molecule or ions is distorted. Okay? Right. So remember, the more electrons you have, the more polarizable you are. The bigger the atom you are, the more polarizable you are. Okay, so meaning smaller size atoms are less polarizable because they do not have uh, more electron cloud to distort na. While larger size atoms such as your xenon and your iodine are more polarizable. Alright, so because their electron clouds are easily distorted or induced. Okay, so remember again, hard acid has a lower size. Okay, lower size meaning they are less polarizable. Hard as soft acid naman are large in size, meaning they are polarizable. Okay, soft acid has low charge and hard acid has high charge. Okay, the same is true to their bases. Okay, to soft acids and soft bases, or so bases or hard bases. Okay, all right. So again, the higher the size of your atom, the more electrons you have, the more polarizable. Okay, the higher your polarizability is. Okay, so small ions right here has has great polarizing power, because the power of cation to polarize in an ion, it can actually induce, okay, your ion right here, meaning it has a great polarizing power, while your big atoms, okay, are highly polarizability, okay, or highly polarizable. Okay, so polarizability is the tendency of an ion to be polarized. Key takeaway: small size atoms is less polarizable, large size atoms are polarizable. Okay. All right. So again, don't be confused. Hard acids is does not equate strong acid. Ang soft acid does not equate weak acid. Remember that strong acid completely dissociate in water, and weak acids are partially dissociates into what in a solution, diba? So these things are different concept. Okay, don't interchange the two. Okay, so we have your hard and soft concept. Remember that hard acids are strongly polarizing and hard bases are more polarizable. Okay? Right, so are less polarizable. Right? So soft acids naman are weakly polarizing. Okay? While soft bases are highly polarizable um due to their big size, no, and small charge. Right? So meaning if you have a hard interaction, you would form your ionic character because there is no distortion. Okay? Right. So soft acid and soft bases interaction naman forms covalent character because there is sharing, no? Tas meron nangyayaring distortion. Right? So mas covalent ang bonding due to the larger size of your anion. Okay? Right here. Or your soft base. Okay? Right? Alright. So, right. So, right. Again, hard is your ionic character na because it's small. Okay? Ang imo ions. Small soft is covalent because you would have big anions right there. Right. So, Pageant rules summarizes the factor that affect polarization. In terms naman of cation, ionic, in terms of Pageant's rule, no? Pageant's rule summarizes the factor that affect your polarization. Okay? In terms of your cation, right? Ionic ionic character would have a large cation size. Covalent character, okay, covalent compounds would have small cation size. So in this trend right here, you should actually see that in terms of covalent character, lithium right here is the smallest, right? Lithium is the smallest. Okay? Yeah, lithium is the smallest. Cesium ay ang biggest. Okay, so since it has the smallest cation, okay, so it would have the greatest covalent character. Okay, so for your anion naman, ionic compound has small anion size, large anion size for your covalent compounds. So in terms of covalent character, you actually need to compare the anion right here. Note that the anion for a covalent compound would be big, no? So since iodine is a lot bigger than fluorine, this lithium iodide would have the greatest covalent character. All right, so that would be it. Now, lithium iodide would have the largest covalent character because it has the largest anion. Okay, so charge on ions naman, okay, in terms of your ionic compounds, the charge would be low, and your covalent compounds, the charge would be high. Okay, so in comparing the covalent character of these two compounds right here, note that aluminum would have 3 plus, magnesium have 2 plus, and sodium would have a plus 1. No? So, charge difference is by 1. So, aluminum would be the compound with the greatest covalent character on it. Okay, so for your electron configuration of cations, for ionic, okay, it would follow an octet rule. For covalent, it would have the pseudo octet. Okay, pseudo means not octet. Okay, comparing the covalent character of your zinc chloride versus your calcium chloride. Okay, remember that your zinc, okay, is actually a transition metal, no, a D. Uh, it has a D orbital on it, no. So it would have an pseudo octet. Okay, so 18 electrons yan siya is zinc 2 plus, while calcium would follow the at 8 no octet or the octet, I'm sorry. Meaning that your zinc 2 plus has more than 8 electrons, no? It has 18 electrons compared to your calcium 2 plus. This one is an alkaline metal. Okay, does not fall in the D transition metals. So your zinc chloride um would be the more covalent, no? So, dapat ganito to dito. Okay? Right? So, I'll correct this one in your slide. Right? So, I hope I'm being clear with this one. Okay, so, right? So, remember the trends of your ionic and covalent in terms of their cation size, anionic size, charge on ions, and electron configuration of your cations.